Let's talk about something that costs companies trillions of dollars, but most people have never even heard of. It all comes down to a simple question. How are the different pieces of your software connected? Or, how stuck together are they? It turns out this one technical detail has massive, and I mean massive, hidden financial consequences. We're going to unpack all of this by following a project manager, Taraneh, through one very, very expensive Monday.
And this is Misha. This quote, it's the heart of the problem, isn't it? If you've ever written a line of code, you have felt this exact frustration. You fix one little thing, and suddenly two other things you didn't even touch just break. It feels like you're playing whack-a-mole. But this isn't just bad luck. It's a symptom of a much deeper, more costly issue that's baked right into the code itself.
So we're going to be a fly on the wall for our project manager, Taraneh's entire day. It's a day that starts with a crisis and ends with a small but incredibly important victory. And each step in her day is going to peel back another layer of this problem that starts with a few lines of code but ends up right on the company's balance sheet.
Okay, so it all kicks off at 8:47 a.m. on a Monday morning. Of course it's a Monday. Taraneh's big project is suddenly in deep trouble. Now, get this. They're already in week 7 of a 12-week project, the budget is super tight, and a change that was supposed to be simple has brought the entire development team to a grinding halt.
And here is the culprit. This is the technical problem at the heart of it all. On the left, you see what the developer, Misha, sees. One part of the code, the menu display, that seems to just contain all the tools it needs. But what Taraneh, our experienced PM, sees is the reality on the right. This code isn't just using other parts, it's practically welded to them. She sees code that is tightly coupled. Think of it like this. If you want to change one little piece, you risk shattering the whole thing.
So here's where the rubber meets the road. This isn't just some abstract coding problem for engineers to argue about. Oh no. This is a business problem, plain and simple. And Taraneh knows she has to translate this technical mess into the only two things her project sponsor really understands: time and money.
And wow, this table just lays the damage bare. It is brutal. A menu feature they thought would take 3 days, it's already eaten up 8. The cart feature tripled in time. All in all, what should have been 9 days of work has exploded to 31. That's a whopping 22 days behind schedule, which translates directly to a $15,000 hole in the budget, all because the code was stuck together.
Now here's where things get really crazy. Taraneh's $15,000 headache, it's just one tiny little symptom of a massive global disease. Let's zoom way out from this one project and look at what this problem is doing to the entire economy.
Yep, you're reading that right. $2.41 trillion with a T. That's the estimated cost of bad software quality to the US economy alone in a single year. Every little delay, every bug, every project overrun, like Taraneh's, it all adds up to an economic drag that is just mind-boggling.
So where does all that money even go? Well, have a look. A huge chunk of IT budgets, we're talking up to 40%, isn't going towards building cool new things. Nope, it's being wasted just keeping the lights on, maintaining poorly built systems, and fighting this thing called technical debt, which is exactly what tight coupling creates.
And you can see how this absolutely crushes developers. They spend a staggering 42% of their time not building the future, but fixing the mistakes of the past. Just stop and think for a second about what we could create if nearly half of every developer's time wasn't spent on rework.
Okay, enough doom and gloom. The problem is huge, it's expensive, we get it. But the good news is there's a cure. So now let's get to the good part, the solution that Taraneh starts teaching her team. It's a way of thinking called loose coupling, and it's all about building software that's flexible and cheap to change, right from the very start.
The main tool in the toolbox for this is something called dependency injection. Now, I know it sounds super technical and complicated, but I promise you, the idea behind it is incredibly simple. All it means is that instead of a component building its own tools inside itself, the tools it needs are just handed to it from the outside. That's it. It's a mindset shift from I'll make everything myself to just give me what I need to do my job.
And this is the absolutely brilliant analogy Taraneh uses. Tight coupling, that's like welding a car's engine directly to the frame. What happens if you need to fix the engine? Well, you got to get out the cutting torch and tear the whole car apart. It's a nightmare. But loose coupling, that's like using standard bolts and engine mounts. You can just unbolt the old engine, pop in a new one, and you're back on the road. It's designed for change.
And here's what that actually looks like in code.
On the left, in the before world, the order processor is hardwired to one specific database and one specific email service. It's stuck. But look at the after on the right. It doesn't build them itself. It just asks for any kind of database and any kind of email service. They get passed in from the outside, which gives you total freedom to swap them out whenever you want.
So Terrain breaks it down into 3 simple rules for her team. First, depend on the contract, the what, not the specific implementation, the how. Think of it like a wall outlet. You depend on the shape of the plug, not the power plant that's miles away. Second, dependencies are passed in, not created inside. Your toaster doesn't build its own power plant, right? It gets power from the wall. And third, and this is key, the class should know as little as possible about how its dependencies work. It's called information hiding, and it keeps everything clean and simple.
And if you're still not convinced, the team's senior dev, Arjun, shares this horror story. Because their code was welded to the real Stripe payment service, every single test they ran actually hit the internet. It was slow, they kept hitting their limits, and they were literally paying fees just to run tests. With loose coupling, they could just pass in a fake payment service for testing. Problem solved.
So, the team gets it. They bite the bullet and they spend a little time refactoring the code to fix this problem. Now, let's look at the payoff. Because this was never just about writing pretty code. It was about getting real results in time, money, and maybe the most important thing of all, team morale.
And the results are pretty dramatic. By investing just a few days fixing the code, Terrain now projects they're going to save 15 days of work down the line. That gets the whole project back on track. They're now projected to come in $8,000 under the revised budget. And as a bonus, their tests run 3 times faster. That is a huge win.
And here we are, full circle, back to Misha. Her initial frustration is just gone. It's been replaced with this incredible feeling of freedom. And her question, why didn't they teach us this in school? Man, that one really hits home. Sometimes you have to feel the pain of a bad design to truly, deeply appreciate the absolute joy of a good one.
So, if you're going to remember anything from this, let it be these 4 things. 1. Stuck-together code is a hidden tax on every single project. 2. The secret to freedom and flexibility is to give your code components their tools. Don't let them build their own. 3. The goal is for every piece to be a little bit dumb about the other pieces. And finally, use clean contracts or interfaces so your components can work together without being chained to each other.
And that brings us to the final question, one for you to take back to your own work. In your project, in your company, can you replace a window without tearing down the whole wall? Are you building things that are welded together, where one change means a massive demolition job? Or are you building with standard parts, where things can be swapped out, improved, and maintained with ease? The answer to that question could be worth millions, or, as we've seen, even trillions.